Hello Algebra, it's Grow here, and we're going to talk about target 1.6, which is using the rules of exponents to simplify expressions, and we're starting on page 19 in our Algebra Chapter 1 packets. So, we're going to start with talking about what an exponent really is, and most of the stuff is going to be pretty simple right away, and we'll get into the rules pretty quickly. But what does this mean? Well, this means negative, and then 9, you got 3 9s, so it's 9 cubed. We're not looking for an actual number right now. We just want to realize what that power means. And this will end up becoming a negative number. And the reason this is you've got a bunch of positives multiplied together, which should give you a positive, and then there's one more negative left out there. So a negative times a positive is a negative. But really just focusing on what's being raised to the power. Only the 9s are being raised to the power. However, the second one, this is going to be negative 5 to the third power, where the negative's on the inside. And this will also be a negative because if you multiply two negatives together, you get a positive. But then you're multiplying a positive by this negative left over. And so you end up with a negative number. Anytime that there's an odd number of negatives, so like 3, 2 of them are going to pair up and the last one's going to be left over. However, if there were 4 of them, can't write 4 and write 5 and say 4 at the same time, these two negatives would pair up and make a positive. These two negatives pair up and make a positive, and positive times a positive be a positive. So keep track of signs. They're actually the number one thing people are going to lose points for kind of as you go by. They're little devilish things. They're not huge issues, but they are big issues. Now this one's got 1, 2, 3, 4, 5 y's, so it's x times y to the fifth. And that's all powers mean. It's how many of these things do we have. But you got to realize that this power implies these 3 different multiplications. So there is this, comparison between exponents and multiplications. If you want to expand them, that's the easy way. And you're going to use this version over here to show a lot of the rules. So I don't really need to do all of these for us. But I guess it's really not that bad, except for the fact that what if this was a 2? What if this was a 21? You wouldn't want to expand all that out. Alright, let's move on to some of the rules. Before we do the rules, let's talk about the vocab. So, when we talk about an exponent, we're talking about the number up top. So, exponent is 4, and the base is 2. Now, in the second version, the base is negative 2. So, whatever is being raised to the power. Now, if you had like a 2x raised to the power of 4, I could consider this as 2 separate ones, but I would say the base is 2x, and the power, or the exponent, is 4. Okay, so let's see if we can get some rules down. Now, the first rule is the product rule. And to do that, we're going to look at a little bit of an expression and some expansion. So let's see here. If we expand this out, we've got 2 x's and then 1 more. And if we condense it, we end up with 3 of them, because we can just count them. And over here we've got 2 x's times another 2 x's, which makes 4 x's. Now here we got 2 x's here, we got 3 x's here. Now if we count them all up, we've got 5. So what do we notice? Well, we're going to add the exponents. So if you look here, now this one's a 1 whether you realize it or not. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. Yeah. So we wouldn't want to really write this out. I mean, x to the third is no big deal, but x to the 100th, yeah, we don't want to do that. We just want to write it as x to the 103rd. Yeah, that's nice. And people don't generally have a huge issue with that, but when they want to write down the general rule, they go, I have an n, what in the world is that? So when we multiply, we're adding our exponents, and there is an m plus n exponent here. So that's our actual rule. But to tell you the truth, this is almost better for most students. They can see this, they can feel it, whereas our more direct version here, the product rule, it's a little harder to see, a little harder to feel. Alright, let's see what's our next rule. Oh, yeah, before we get to the next rule, let's just kind of use our product rule. Now, what you have to realize is this 4 is up top, it's just going to chill up top. On the bottom, I know we have 3 of these here, but we can look at them in any order. So since they're multiplying together, we just add all the exponents. So 4 plus 3 is 7, plus the one more is a to the 8th. Now the biggest mistake people will start doing is they'll start using these rules of exponents on numbers. So x to the 13th, because 5 plus 8 is 13, but then they start doing crazy things like saying 3 times 8 is not 24, but 11. It's definitely 24. The rules of exponents don't apply to numbers. Now, be careful that you don't just lump all these together. This should be 2x to the 5th, y to the 8th. Add the y's, there's nothing to add to this x in the middle. Alright, so that's the rule we've got so far. So that's what happens when we multiply. Let's see what happens when you take an exponent to an exponent. Alright, so what does 2x to the third mean? Well, that means I've got, oh, sorry, not 2x, x squared to the third times x squared times x squared. Now I'm going to add up all these 2's. 2 plus 2 plus 2 is 6. Alright, we got x to the fourth squared, so x to the fourth times x to the fourth. 4 plus 4 is 8. I'm hoping we see this before we get to the next one. We have 3x to the thirds, because we have 3 of something. And I could even write this out as x times x times x, x times x times x, if you really, really want to. But the whole idea here is there are 9 of them. So what's the rule when you have an exponent to a power? You are going to multiply powers. I've heard this called the superpower rule before, but I don't know. I just call it an exponent to a power. So what do you have here? We have x to the third to the 100. So we're really going to write out x to the third 100 times and then add them all up? No, we're going to multiply them. It's x to the 300. Now, these two rules, x to the third times x to the 100, they do get mixed up often. And you really got to think about this. This is 100 x's and this is 3 x's, so we better have 103 x's. That's not what we have here. We have x to the third 100 times. If you have 3 of something 100 times, you know, that's this. The whole idea of all the seats in the arena that you've seen every time you've ever been taught multiplication. That's why you multiply. That's why you learn how to multiply, so that you don't have to add up these 3 x's 100 times. So keep in mind what you're really, like how big of a number you should have. Should you have 100 and then 3 more, 103, or are you going to have a whole lot of 3's? Should you multiply them? Alright, let's try to use this real quick here. Okay, so now one of the things you can do here that you might not be sure about is every single one of these things. You can write this as a squared times y to the third squared over x to the fourth squared. But yes, you can do something like the distributive property where we just simply distribute. Exponent to an exponent is multiplication, so this would be a to the fourth. Y 3 times 2 would be to the sixth, and then x to the eighth. It's as easy as that. What do you know about that? I think I've already answered that. I feel like this is a repeat question, but we're multiplying the exponents. So what are our rules? If you have x to the n, base raised to a power, you're going to multiply m times n. If you've got a product here, you're going to just distribute across that. This would be y to the, now realize it's 1. 1 times n would just be n, not 1 plus n. And then m times n would be x to the m times n. And it's tricky as, you know, variables here, but think back to this example. 3 times 2 was the 6. And even if there's a division sign in here, this would be x to the m times n divided by y to the n. You can distribute them. Okay, let's do a couple more examples here. Okay, we're just going to do a few here. Let's do B. Let's do C and D. I'll leave it A and B. So we're going to distribute this across everything. So 3 squared, now that's the big thing. Don't forget, that's 9. That's not 6. when you multiply exponents, like 2 times 1 here, you're going to get 2. When you multiply 3 times 2, you're going to get 6. But 3 squared is 3 times 3. So the rules of exponents do not apply to numbers. This is 3 to the first. So when I square that, it makes 3 squared, which is our 9. And on the bottom, only the a squared b is being raised by the 3. So that 2 just chills there. And it becomes a to the 6, b to the third, and we are done. Now one of the things we're going to talk about in the next video is what happens when you have x's on top and bottom. Don't have that yet, but we're going to have to deal with that shortly. Alright, let's try D here. So, order of operations. You can't distribute between the 2 and the 4 yet. You have to do exponents before you can multiply. So, 2 to the third is 2 times 2 times 2. That's what this 2 to the third is. It's not 6, it's 8. That's 4 times another 2 is 8. Alright, and then when you take 3 times x squared, that's x to the 6, times, you can leave the parentheses here if you want, but the second that I've done the exponent, there's nothing outside the parentheses to worry about. Alright, let's distribute this squared in here. We get 16, x to the 6, y to the 4th. Now I can compare these two sets. 8 times 16, oh, that's annoying. Alright, let's see what we got here. 6 times 8 is 48. 8 times 1 is 8, plus 4 is 12. Alright, 128. And I know it's not fun to do something like this, but it really doesn't take as long as students make it out. They just, I don't know what 8 times 16 is. Well, I don't know either, so you just write it down. Alright, what do we got? X to the 12th, because now when we multiply, we add the exponents. Again, that's going to be the hardest thing for us, is to keep track of what's really going on here. The reason for that, again, is there are 6 x's here. That's what this means. And we have 6 x's here. So how many x's do we have? I sure hope we have 12. And then y to the 4th. And that's our answer. Okay, let's see if we can do one more rule in this video, and then I think we're calling it a day. Actually, let's call this video a day, because that's the end of our first day of notes. After this is just practice. So, go back through things. But, let me recap a couple things here before I go. When you are multiplying, that means there are 2 x's and 3 x's. Therefore, there should be 5 x's. When you're raising a power to a power, it's not saying there's 2 x's here and there's 3 x's here. That means there are 3 of this thing, which is x squared times x squared times x squared. It means there are 3 2's. 3 2's is another way of saying 6. So, confusing the rules is going to be the hardest things for people. But I don't want you to think of them as rules. I don't want you to just focus on the rule that when you multiply, you add the exponents. I want you to focus on why you add the exponents. You add these exponents because this is 2 x's and 3 x's. So how many x's do you have? You have 5 x's. Again, that same rule is what makes the second version multiplication. So you need to know the rules, but focus on learning the rules because of why they have to be what they are. Alright, so finish up the notes. If you anything I skipped, go over them, and then we'll move on to the second video when you're ready.